Hello everyone, hope you are doing well. I'm Reza, founder of the optimizationct.com. In this session, we will solve a linear programming model using the graphical methods. Then we will solve the same model using the GAMS software. And finally, we will use the online solver provided by website www.optimizationct.com. At the end, we will compare the result of these three approaches. So let's get started. Here is the outline of our session, presenting the model, solving the model graphically, solving model using the GAMS softwares, and solving the model online via the website www.optimizationct.com. The linear programming model we will solve is as follows. We have two variables and four constraints. The objective function is to maximize the 24x1 plus 20x2 subject to four constraints. x1 plus x2 is less than 12. Constraint number 2, x1 plus x2 is less than 20, 2x1 plus 4x2 is less than 24, and 30x1 plus 40. x2 is less than 48. x1 and x2 is non-negative. To solve this model graphically, first we plot the feasible region by graphing each constraint as follows. We start with constraint number 1. Plot the line using 2 points here. 12, 0 and 0, 12. Okay, 12, 0 and 0, 12. This is the constraint number 1. Since the origin satisfies this constraint, it means 0 plus 0 is less than 12. So the area below this line is visible. Move on to the next constraint. Plot the line using 2 points, 12, 20, 0 and 0, 20. Okay, 20, 0 and 0, 20. This is the constraint number 2. The area below the line is visible because the origin currently satisfies this constraint. 0 plus 0 is less than 20. Constraint number 3. Plot the line between 2 points. 12, 0 and 0, 6. Okay. Plot here. 12, 0 here. And 0, 6 here. Is 2 points. This is the constraint number 3. With the area below the line is visible because the origin satisfies these constraints further. Constraint number 4. Plot line using these 2 points. 12, 0. Sorry about that. 16, 0. Okay. One more time. 16, 0. And 0, 12. This is for constraint number 4. Okay. 16, 0 and 16, 0 and 12. This is constraint number 4. Again, identifying the feasible area below this line. Considering the non-negativity constraint for variable x1 and x2, so this is the feasible region for x1 and x2. In the first quadrant, The feasible area is the intersection of the all constraints. So here, with the other color, yellow. Okay. This is the feasible region for this model. Next, we graph the objective function for two values. For the other color, like green. Okay, nice. For z is equal to 24, we have 2 points, 1, 0, and 0, 1.2. For z is equal to 96, we have 2 points, 4, 0, and 0.4.8. Okay, we plot with the other color, yellow, green. Okay, 1, 0, and 1.2 here. This is for z is equal to 2 point. Z is equal to 24, sorry. Z is equal to 24. For z is equal to 96, we plot 4, 0, and 0, 4.8, something like this. This is z is equal to 96. By plotting these two lines, we observe that as z increase, the line move upward. So you can see here. The optimal solution is at point with the parallel line with these two lines is this point. So you can see that this point, it means 12, 0. Here, z is equal to 288 and x star is 12 and 0. This is the optimal solution for the model. For the model using the GAMS software, we do the following. This is the code in GAMS for solving the model. We define with other code. Okay, we have I is equal to 1 and 2. We have two variables, x1 and x2. We know that x1 and x2 is greater than 0 or non-negative or positive here. Z is free in sign, so we just write variable objfu. We have one objective function and for constraint specify the objective function and constraint in equation section here. Okay, obj cons 1, cons 2, cons 3, and cons 4. Here obj fu is equal to 24x1 plus 20x2. We have 4 signs for inequality or quality in GAMS. Equal, E equal, it means equal. Equal, L equal means less than. And equal, G equal is it means greater than. So Z or objfu is equal to 24x1 plus 20x2. Constraint number 1, x1 plus x2 is less than 12. x1 plus x2 is less than 20. 2x1 plus 4x2 is less than 24. And 3x1 plus 4x2 is less than 48, as we state in the model. Use the command solve to solve the model. We use the NLP solver NLP is a special, LP is a special case of the NLP, so we can solve the model with NLP. We have the maximization form in order to maximize OBJ, FU, or Z. Display the result using the command display x.l or x level of the x optimal solution. So what happened? We run the model, we open a new file, we prefer the model before. Okay, copy and paste. This is the model. Sorry. Okay, well done. We just run the model by clicking the red arrow. Okay, you can see the optimal solution in display. X1 is equal to 12 and other is 0. And objective function is 288. We can see the result in this part. Solve the model using the online software. We visit the website www.optimizationct.com. Okay, this is the optimizationct.com. Okay, online OR solver, primal simplex methods. And this is the online solver for linear programming using the primal simplex methods. Okay, we have 4 input variables. What is this variable? Okay, this is the model. Okay, n is equal to number of variable, but not 2. We need x3, x4, x5, and x6 to make this model in the standard form. So we have 6 variables. And we have M is 4 constraint. EPS here, EPS. The precision of the optimal solution is equal to 0.0001. And how we can find A? Okay, we rewrite like this. Right hand side x1, x2, x3, x4, x5, x6. Okay, right hand side for the first constraint is equal to 0. x1 equation 24. 20, x3 0, x4 0, x5 0, and x6 0. Right hand side for the first constraint is 12. x1 1, 1, 1, 0, 0, 0. Second constraint 20. 1, 1, 0, 1, 0, 0. Right hand side for the third constraint 24. 2, 4, 0, 0, 1, 0. And the last one, right hand side is 48. 3, 4, 0, 0, 0, 1. So this is the A matrix or coefficient of the matrix here in this box. Okay, I prefer this matrix before here. Okay, we visit the website. We have 6 variables, 4 constraint, precision is equal to 0.0001 and A. So we just press the run. And you can see that the objective function is 288 and x1 is equal to 12, and the other is the basic variable. We just need x1. We can see the result here. In this example, some constraints are not binding in the feasible region. So you can see here, for example, constraint number 4, constraint number 2. What are these constraints are called? Please share your answer in comment. We will explore this question in the future video. Thank you so much for watching us. If you have any question or need help solving a model, feel free to contact us by email or filling the contact form from our website www.optimizationct.com. Do not forget to subscribe our YouTube channels to stay updated with our video. Thank you so much and goodbye.